Right, so we're very privileged to have Torben P. Pedersen with us today for our discussion. This is our applied cryptography class, our MSc class, and the great thing is that the students have been doing smart contracts and blockchain for the past couple of weeks. We did a little bit around zero knowledge proofs and other things like that. Looking to the future for our cryptography. So this is a great opportunity to really hear from a world leader in this field, both from an academic point of view and also from an industry point of view. There are few people that have that experience. Either you're a pure academic or you're a pure industrialist. You see it from both sides. So I think this is a really great opportunity for our students to really hear from yourself. So you've worked in so many core areas: verifiable secret sharing, digital wallets, group signatures, and in the early days, well, we call it electronic cash. We won't call it Bitcoin or cryptocurrency just now. We'll call it electronic cash. I think you're famous for the Pedersen commitment, the Cham Pedersen commitment, and also Pedersen verifiable secret shares. So I think my first question is what got you into cryptography?
Yeah, so what got me into cryptography was when I was doing my master's study. I had a very inspiring professor in Peter Landrock, who founded actually the crypto group at Aarhus University back in the 80s. And yeah, he got me interested in it because of the combination of mathematics and computer science. I was studying computer science. Peter Landrock was a mathematician, but I like this cross field between using mathematics and computer science.
That's great. And in the 1990s, I think you worked on secret shares and threshold encryption. And we can actually see now, I think the Coinbase cryptology library includes Pedersen verifiable secret shares. Where are we going with secret shares and things like distributed key generation? Do you see that as the future of storing keys?
Yes, I think it'll be used in the future. Now, one of the worlds that I'm coming from is I've been working on cryptographic solutions for the financial world, for banks, and for many years they have very much relied on hardware security modules, HSM, where they just store the keys and generate the keys in an HSM, and they'll continue to do that. But we also see now a trend towards rather than having the keys in one HSM, having them at several places, and using secret sharing for that, using shares of the keys and combining the results. So that is one thing. Another thing is that when you're using an HSM, even if keys are protected by the hardware in the HSM, at some point there's going to be a master key or a root key controlling actually the keys in the HSM. And secret sharing is also used to manage that root key, because it's simply too valuable to have it at one person. So yeah, so that it will definitely be used, and I also think verifiable secret sharing will continue to be used.
It's great, and you worked with one of the great innovators in digital currency, David Cham, around the start of the millennium. And what do you remember about his drive and vision? And do you think his vision has been realized in this modern cryptocurrency world?
Yeah, that's a good question. So it was back in the end of the 80s when I did my PhD. I met David Cham, and he was actually one of the persons who urged me to work on secret sharing schemes and applying shared secrets in cryptography. So he was one of the persons who led me into this work. As for at that time, David was working very much on electronic cash, as he called it, and he had this this problem. He had this great idea with blind signatures, but had the problem with detecting double spending. I think that problem, I mean, one of the big things about the blockchain is that it helps solve that problem, because now we have a central place to register whenever a coin is used, and can prevent double spending. So you could say, from being a little bit not that practical, at least I could say in the 80s, the blockchain technology has helped making some of his ideas more practical, and they, I mean, they are used now in the blockchain world. So I think that's very interesting. And actually, the idea of blind signatures itself is also used in many places. So yeah, I think some of the visions that he had at that time, yeah, they are now real. It is taking a long time for some of them, but that's how it is.
Yeah, because I think the EU are now looking to perhaps ban these privacy-preserving cryptocurrencies. So, do you think that's the wrong way to go?
I think that if you want to, now if you just look at blockchains in general, I think if you want to have use blockchains widely, we have to accept that they're going to be used in a world that is regulated. But I don't think there's a contradiction between having some level of anonymity and then have a regulated world. So now I'm working with blockchains in Concordium, and one of the things that we are doing, which I think is different from many other blockchains, is that we actually have a layer of identities as a core part of our layer 1 blockchain. But we are using zero knowledge proofs so that people can actually create accounts on the blockchain without revealing the identity. They can determine which personal attributes, if any, that they can reveal on the chain. So they can use our blockchain completely anonymously. But if there is what we call it, the suspicious behavior of a user, it is possible for a number of designated parties, and here again we have secret sharing used. It is possible for a number of these parties, based on a court order, to actually identify the owner of an account. But that can only be done by this set of persons. So I would say, I understand, and I think it's valid that there's a need for regulation and to identify people behind transactions, but that does not have to imply that we cannot have privacy in the transactions. So I think these two things can work together, because we have so many strong cryptographic protocols, mostly based on zero knowledge proofs, that really allows this and also uses some of the more some of the newer cryptographic schemes. And I would say, I mean, one example which I think is really good to learn from is we had this big Phoenix hack back in I think it was 2016, and the authorities knew where the money was, but they didn't know who owned the accounts behind these the persons behind these accounts, but only when they tried to withdraw the money, they could get the persons. So it's a long time to wait, for almost 6 years, to catch the people. That should be possible to do faster, because why should we protect the anonymity of people who are hacking our systems? So I think it is a fair request, but we have to do it in a balanced way and still allow privacy in the transactions.
Yeah, I think it's a great approach, because things like money laundering and so on, the banks need these checks, and how do they balance between anonymity and complying with various things like that that protects us against criminals and so on. So I think your approach is excellent. I could see it working in things like healthcare and in other areas where identity is very important. I think it would work well. So you're famous for the Pedersen commitment, which blinds transactions. What was your motivation for creating that? Could you tell our students how it works and how might it be used now
Yeah.
and in the future? So there's 3 questions there. What was your motivation? How does it work? And where is it going?
Yeah, so my motivation for this really was that I was working on verifiable secret sharing as part of my PhD thesis. I had some solutions for where you could distribute a key to a signature scheme, for example, in an elliptic curve or a discrete log-based system. But that, and I could do it in, with verifiable secret sharing, and you probably know how to do that. But then I just thought, just as we have, why couldn't we just share a key without revealing any information about it? Well, because if the key is shared this way, if you can compute the discrete logarithms, you can know the secret. And then I started to think about it. I had seen some papers where this idea of using G to the S times H to the R, this product, which is in a commitment in other applications, and I thought that was very neat. Yeah, and then I was just playing around with it and seeing that how it would fit in with Shamir secret sharing, and then it turns out to work. And so it really came from the need for secret sharing and verifiable secret sharing. That is what I needed it for.
Great. And where do you think it's going? So we see it in Mimblewimble and some of the privacy-preserving cryptocurrency applications. Where do you think your commitment will actually end up? Could we see it in elections, online voting, and things like that? Where do you think it would be best placed?
Yeah, I think it will continue to be used in many MPC protocols, because it's very easy to argue when you use this commitment scheme, because you have a strong secrecy protection of your secret. So yeah, I think it will continue to be used in multi-part computations, and these can be used for. I mean, today they're used for auctions, of course, but it will also be used for, say, boardroom elections, smaller elections. Whether we will have electronic voting systems based on multi-party computations for like national elections and votings, I'm not sure, because then there are so many other things like coercing votes which come into play. But it will certainly be used, and I think multi-parts. I see a good future for multi-party computation, secure multi-party computation, and as such, I also see a need for the commitment schemes and the secret sharing scheme that I made back in the 90s.
Yeah, that's great. And the whole concept of wallets has changed. So you published papers on wallets, and David Cham obviously talked about a wallet. For some people, it's your private key. You have control of your transactions in the wallet. But now people are talking about having things in your wallet. And I find there's a lot of confusion around it. So has the whole concept of a wallet changed, and how do you see it evolve in the future? Sorry, I talk about a digital wallet.
No. Yeah. So yeah, I think what I did with David Cham on these wallets was really the main goal was to provide a mechanism to protect the privacy of the users. That maybe you could not be in control of everything, but it could be, there's a little piece in the wallet that he could, the observer, that he could trust, and that would help him protect his privacy. I think for if you look at, for example, the wallets which are used on blockchains to keep cryptocurrency, they are of a different nature and probably a different purpose. So I'm not really sure. To be honest, I haven't thought too much about the work I did on the wallets back in the 90s recently. I don't see if it fits very well with the current blockchain wallets, for example.
Good. And so can you tell the students what you do now and what it is that drives you?
Yes. So for many years, I worked at a company called Cryptography, which is a Danish company, a spin-off from the university, which provide cryptographic solutions for the financial sector. And And of course, I followed the blockchain a little bit from a distance. But then 3 years ago, I got the possibility to start working at Concordium. I thought their concept of having an ID deeply integrated in the core blockchain layer was a good idea. Concordium has a very close cooperation with the crypto group at Aarhus University with persons like Ivan Damgaard and Jesper Buus Nielsen, both of whom I know very well, of course. And so it was a good opportunity for me to get back into this area and to work with the people from the crypto group at Aarhus University, and also work with people from ETH as part of Concordium. So it was a bit like coming back, I could say, because it was interesting to see that many of the techniques that we worked on, in the 80s and 90s, were actually finding good use in blockchains. And then there was of course, a lot of ideas added to this to make it practical for blockchains. So there was sort of recognition for me. Good to see things being used, but also nice to see the new things that have been added. And I think a lot of good ideas have been added in the blockchain research. So that was interesting.
Great. And you also work in the area of serial knowledge proofs, and you've outlined that that's a core part of what you're working on technically. And they all started with the Fiat-Shamir method, but they've really advanced so much. Our students learnt about Fiat-Shamir today, and that's the kind of anchor point for much of these methods. But where are we with the state of the art just now, and where do you think they're going to go in the future?
Yeah, I think it's interesting that this Fiat-Shamir concept of making serial knowledge proofs or non-interactive serial knowledge proofs is, I mean, they're still being used. We use it in our blockchain today for some of the proofs where it's possible. And actually, the serial knowledge proofs is one of the areas which I think has advanced the most while I've been away from research. And that has been very interesting to get to see that, I would say. I don't have a deep, I mean, I don't have a deep understanding of all the different serial knowledge protocols, but I think it is serial knowledge proofs. I think it's a very intriguing concept, and actually that's what I worked on when I did my master's thesis. I thought it was really interesting. The first ideas with serial knowledge had just been published at that point, so I thought that really intrigued me, because I thought it was so funny that you could prove something without revealing anything about the fact that you're proving. So yes, so we'll see more advances in serial knowledge proof. I'm sure about that, and we'll see more uses of serial knowledge proofs. I think getting back to what we talked about before, protecting privacy while still accepting we live in a regulated world. I think serial knowledge proofs are a key concept to achieve that. We need the proofs to be better all the time. So we will definitely see advances. I think we've seen a lot of advances recently, but we'll see more.
Thank you. And what's the core difference between the cryptography that we'd use in traditional systems, such as in our financial world, where it's used extensively, and within a blockchain solution?
So I think there's one thing which is a very big difference. In the financial world, it is almost unheard of to use a crypto algorithm which is not specified in a standard, in a NIST standard or an ISO standard, because banks will simply not accept to use crypto algorithms which are not standardized. It will be too big a risk. Whereas I would say in the blockchain world, there's a very fast adoption of new crypto algorithms, new protocols that help achieve some of the goals. Sometimes I would even say maybe it's too fast. I mean, there's a risk if you adopt a new algorithm too quickly before it has been examined exhaustively. So I think that is the biggest difference. So there's in the financial world, it's very conservative. In the blockchain world, people jump on new algorithms, new protocols, trying to make life easy adding new features based on that. So that is interesting, but it's also maybe a little bit scary sometimes.
Yeah, and how do we best trust these systems? How could we make sure that we have strong digital trust? And obviously the human trust is very important, and we've never really addressed the linkage between digital trust and human trust.
Yeah, so I think it comes at many layers, and one level is definitely that we have to use good crypto algorithms. We have to use good protocols that are secure, that cannot be broken. But there are many other things around that which I think it's worth considering. And I think it's, if you look at the financial world, so they're quite conservative, as I said, but they also have a very strong tradition for auditing their systems, having extensive logging, having all kind of security mechanisms around the system to secure everything. And I see that much more than I see in the blockchain world, and I'll get back to that in a minute. And another thing where I think, say, the traditional financial world is very strong is on key management. As I said, they very often use HSM, so it gives a good level of protection. But even for the keys that have to be handled manually, they have good processes and procedures in place for this. They have audited processes. And if you compare the blockchain world with that traditional world, I think the blockchain world is a bit immature, and that somehow it hurts the trust that you can put it a little bit. So I mean, we've all seen examples in the past with smart contracts, where I would say that quite simple programming errors in the smart contracts, which have caused loss of cryptocurrency, loss of tokens. Recently, we have seen a lot of problems with breaches. We have seen, I think, the recent problem with the Ronin attack, where simply key management was not good enough. It was possible for an attacker to get hold of 5. A key was shared in 9 shares, and you had to have 5 of them to use the key to do something. It was possible for an attacker to get 5 of these shares and actually attack the system. And we need to do that better in the blockchain world also, in order to create trust. Right now, the bridges seem to be a weak point. I still think many smart contracts are also a weak point. So we need to have a better tradition for validating smart contracts, proving that they're correct, having extensive review of smart contracts to avoid these kind of problems. And that is necessary to increase the trust in the blockchain. But one good thing about blockchain, which is the advantage of blockchain over the financial world, I think, is the decentralization. In the financial world, if you can break one computer, you can break the system. In a decentralized system like a blockchain, if you break one node on the chain, one miner, one baker, whatever we call it, you haven't broken the system, because the rest of the nodes running the blockchain will secure the blockchain. So that adds, and that's a strong advantage of a blockchain, I think, and that is what we should build on, and that is what gives a big potential, I think, to make blockchains more trustworthy. We just need to mature part of the systems used in the blockchain world to get the right level. And I even see a way where we can use the blockchain to play together with, say, the systems in the old world, like digital signature schemes. If you look at the EIDAS regulation from the EU, there's a requirement for some trusted third parties, for example, for timestamping or for helping to archive. Why not use a blockchain for that? You can use, I mean, the blockchain could create this trust that you would otherwise need in a trusted third party. And if you can build a blockchain and you can create the trust, having the necessary maturity, I think it is possible to also use the blockchain in relation to these types of systems. But I still think there's a way to go. It's early days for the decentralized systems like blockchain, but it'll be better.
Yeah, It's great. So how are identities created and managed within a blockchain solution?
Yeah, so I know our own solution best, so I can tell you how it works in our solution, in the Concordium solution. And this is, I should say, the concept behind this is described in papers that you can find by even Damgaard and a number of other people. So that is not something I've come up with other people, so I can easily say that I think it's a good concept. But the way it works is that before, so first of all, to say, so on our blockchain, it is account-based. So in order to do anything on the blockchain, you need to have an account. In order to create an account, a person or a company or whoever first needs to go through an identification process with an identity verifier. And that is, we currently have 2 identity verifiers in Concordium, but there could be many, and these are completely unrelated to the Concordium Foundation. But you go through this identification process, and you get, as part of this, so your identity is verified, and then you get what we call an identity object, which is actually based on I think Poincaré-Sandler's signature scheme, which allows the identity issuer to sign something without knowing everything that it signs. Now, using this signature scheme, so the user gets this signature, and using this signature scheme, the user can create a credential, so his personal information that he wants to associate with his account. So that is one thing. He can, it's a type of self-sovereign identities, because he can determine which personal attributes to associate with accounts. Typically, you don't want to do that on the blockchain, but that is possible. Anyways, but this uses zero knowledge proofs to actually prove that the credential that you create is correct and has been verified by the identity provider. So here, zero knowledge proofs are, it's really the central concept, that you use zero knowledge proof to transfer the verification of the identity provider that you have a valid account. And this zero knowledge proof also includes a proof that, if necessary, the identity of the owner of the account can be found by these designated parties that are also in the system. So that really all depends on zero knowledge proofs and threshold encryption. So that is how it works. So the identity is, I wouldn't say it's coded in the account, but the account is built on the identity using zero knowledge proofs. And because it's zero knowledge proofs, the account does not contain any information at all about the identity of the user.
Yeah, very interesting. So Ethereum 2 is going to be rolled out, and obviously there is a big drive against proof of work. And I think the currencies and the blockchains which consume a lot of energy are going to be really barred from usage, especially Bitcoin. So Ethereum's now looking at proof of stake for its consensus, and then also sharding is a big jump into the unknown for them. So do you think those 2 concepts will work, and what are the risks that might be involved?
I definitely think proof of stake works. I think it makes really good sense to me. I think it gives a high threshold to attack a system, because you can say exactly how much does it cost to attack the system, whether you need 50% or 1/3, depending on the consensus protocol. So that, I think, is the right way to go, and it's definitely much more acceptable, as you say, than the proof of work systems. As for the sharding and consensus protocols, I think we're going to see advances in these. One of the big issues with permissionless blockchains is obviously the throughput. It requires it's difficult to process that many transactions. That's definitely also a problem with Ethereum today, but it's a problem, I believe, for most blockchains today. So I think we will see a development to increase. We will definitely see a development to increase throughput. And that could be in the consensus protocols and maybe even in the way the blockchain is used. It could also be with sharding. We are also considering sharding in Concordium, but it's difficult, and I think experience shows that it's difficult to come up with good sharding solutions, in particular when you start looking at transactions that go across shards. I mean, they will be slow, and so sharding can help, but I don't think that's the ultimate solution. We have also seen the Polkadot. It's not going at the idea is good, but it's really a difficult thing to have a good solution for. So this does not. I think there'll be room for sharding, and we will see shards because they can be used in a number of scenarios. But I also think we will see changes in the way the consensus protocols work on blockchains and how much they have to do. So if you look at it from a very high or maybe abstract level, the most important thing I think with a consensus protocol and blockchain is that all these parties which are completely decentralized don't know each other. They have to agree on an order of the transaction. So it is the ordering which is important. And once the ordering is determined, you cannot change the ordering. And I think there's well, I know that there's work being done now to improve in this ordering process to make it faster and faster. And I think once that is faster, I think it's possible to have faster blockchains. Also, of course, in a blockchain, it's more than just ordering because you also need to process the transactions. You need to process the smart contracts. But if you can speed up each of these layers and maybe make them less involved with each other, I think there's definitely a possibility to improve the scalability of current blockchains without sharding. So I think we'll see progress on the scalability on a number of fronts, sharding, but also on the consensus protocols, the way transactions are handled on the blockchain. Because we also have to remember that it is still early days for blockchains.
Good. I think Pavlos would like to ask a question. Pavlos, are you there?
Hello. Yep,
Hello.
I'm here. Thank you very much. Thanks a lot for your insights. I want to ask you, what is your opinion about private blockchains?
Yeah, so I think if it is a completely private, sometimes I have a difficulty to see the advantage of a completely private small blockchain compared to just having a solution with a centralized or distributed database among the participants. I'm not saying that you can probably find scenarios where it makes sense, but I say it's not my favorite cup of tea, to put it that way. But I think that's one part. If you look at a permission blockchain, I can see an idea in having a permission blockchain where you put some requirements on the nodes running the blockchain, so only a certain subset of the nodes participate in creating blocks, processing transactions, because this would, for example, allow you to require that they have strong computing power, so you can process things quickly. But if you say, okay, you would have a permission blockchain for parties that create the blocks, build the blockchain, process transactions, maybe it does not have to be a private blockchain. Maybe you can also make it public so that people can inspect it, see what is going on. Maybe they cannot participate in producing blocks, but they can inspect the blockchain. They can see what is going on. They can verify that things are not changed back in time. So that would, at least for me, if you have a permission blockchain where you can have kind of a public verifiability, or I think that could make sense for me. That makes more sense to me, than put it that way.
That's really interesting. There are a lot of, let's say, companies or organizations that are afraid to put their data in a public blockchain sometimes, yeah, especially if it's sensitive.
Yes, but I don't think we should put data. Basically, I don't think a blockchain is suited for putting data. So a blockchain is suited for putting hash values of the data so it can protect the integrity and make sure it's not changed. but data should be stored elsewhere in storage systems which are optimized to store data. So for me, a blockchain is, it is public. So and you cannot encrypt data, put it on blockchain, because you never know when the crypto system is broken. So my principle is to have as little data as possible in the blockchain, but just use blockchain to verify other data.
Thank you very much. And a follow-up question, maybe for some of our attendees, maybe also a bit more cool. What's your opinion about metaverse?
I don't have any opinion about metaverse yet. I need to study it more closely, understand what it means, because so I don't have a clear opinion about that yet. I'd rather have a qualified opinion than saying something now.
That's great. Thank you very much.
Good. Thank you. So obviously NFTs, non-fungible tokens, are all the rage just now, and they've exploded. And you now see arts and trading, and there's OpenSea is trading these tokens, and there are many risks to it. So where do you think NFTs will go? Do you think there's a long-term need for them? Could we see them being converted into a tokenized economy? Where do you think it will go?
Yeah, yes, I think we'll see different uses of NFTs, and perhaps also, I mean, tokenization of real estate is one of the things where NFTs can be useful and are used, and that makes good sense to me, that you can sell 1/10 of a building in an NFT, and so that I think that will create a new economy. So NFTs, I think we need to see applications maturing again, but the concept of an NFT as a tokenization of something in the digital or real world, that makes good sense to me. I think we can also see perhaps not NFTs, but different types of tokens in relation to ESG. So for handling, for example, carbon credits, carbon offsets, and these kind of things, we also see applications in that area. And this is still at a very early stage, but we will see more applications of that as well. Because we will need, for example, for the ESG, we will need much more. We will see much more control over this in the future, as we're trying to bring down our carbon emissions. So yeah, I say, but if you look at how it's used today for art and different types of art, for me it's more fun. I know there's a lot of money involved, but I see uses for NFTs in other applications.
Great. And I wonder if you could tell us a bit about the Concordium Foundation and what its objectives are.
Yeah, so for the Concordium Foundation, so it's a Swiss foundation, and it is created with the purpose of building a new blockchain, and public permissionless blockchain based on proof of stake. But with this, and one of the center points and requirements for the blockchain was that we should have this identity layer built into the core blockchain, so that the blockchain can be used in a regulated world in the way that I described before. So that is what we are building. We have the blockchain running, and now we are working very much on creating use cases on this, and that's actually one of the things that I'm working most on nowadays. I think it's very interesting to see how it can be used. But I think we all know that it'll take some time to get really good use cases and have broad uses, but there's certainly many possible and potential applications of permissionless blockchains. And again, as I said before, I believe more in permissionless blockchains than in permissioned.
Yeah, and with proof of stake, how do you get the balance right? So you need to incentivize the entities in the proof of stake. They need to put their money in, and you need to give them something back. So
Yeah.
obviously, if it becomes too profitable, then it almost becomes the same problem again. There are too many of these entities. How do you think you can create that balance of incentivizing and keeping them clean?
So that is a very difficult thing to do. So today, so as you said, we do have a reward schemes for so that we can reward the we call it bakers, those who are creating making new blocks. We think it's okay. We're working closely together with ETH, with some people from ETH and the economy side to design the system. So we have a system which is sound and well thought through, but it's a very delicate system, because just small changes in some of the reward mechanisms may change the complete behavior and incentives for different persons. So we are actually in Concordium. We are going to sponsor a research project in this in order to understand this better, because we need to understand this better, and I think that's common for many blockchains.
I think we've got a question from Franco. Franco? Perhaps? Franco? Is Franco there? I think his question was, what are your thoughts on DAO?
Again, it's one of these things I haven't much thought about it, but if you look at it more generally as my thoughts about decentralized governance and decentralized organization, I've mostly looked at it from the point of governance of blockchains, and I think this is for the governance of blockchains. This is essential, because otherwise we're back into the world where you have to trust one party. For example, on our blockchain, the Concordium Foundation, we don't want people to trust the Concordium Foundation in order to use our blockchain. Of course, the Concordium Foundation will support the blockchain. We will stake. Concordium Foundation will stake the cryptocurrencies that we have, but it's important that the blockchain is governed in a decentralized and open way, with I say transparency is a key word for me here. The way it's done is transparent. People can participate in voting schemes for how the blockchain should evolve. So in this world, I think it's absolutely essential. But it's also clear that many blockchains still have a long way to go, and that also goes for Concordium to be completely decentralized. But that's a path that we need to, everybody need to, in the permissionless world, need to work on this.
Great. And you went from academia into industry, and that's obviously a career decision you made, because the papers that you published have such high impact that you could have easily become a research professor in a university and built a team around your work. So what really motivated you? Why did you move into industry?
So I think there were two things. I mean, I've been working with cryptography for almost a decade when I made the change, and I thought I would, at that point, I would like to see how it is done in practice, how cryptography is used in practice. Remember, this was about the time, this was in the middle of the 90s, where we just started to have digital signatures. Public key encryption started to be used. So it was very early days. So it was interesting to see how, I mean, the only system used at that time was RSA. So it was very interesting to see how it was used and how it could be used and influence that. So that was one part. The other part was that I probably got a little bit tired of following all the work that was going on in cryptography, a lot of papers to read, and I think much of it was. It took a long time to. I mean, if you want to follow all topics, it would take a long time, and then maybe you could say I could just focus on a few topics. But then I'd try to go and see how it's used in practice. So that was my two motivations. I probably needed to do something else, basically.
Great. And what do you see the horizon for cryptography in the next 3 to 5 years? What are going to be the major changes? What are the major challenges that we face?
Yeah, so the major challenge is of course the potential existing of the quantum computer. For some crypto systems, I know all the systems based on discrete logarithm and also RSA based on factorization. They cannot be used if we get, and I say if we get a quantum computer. So it will definitely be a challenge to have post-quantum crypto systems in place that can be used instead. And that is one thing. But in particular, we talked about zero knowledge proofs and multi-party computation protocols earlier. All these protocols, they would also have to be adapted to the new world if we get a quantum computer. So I think this is, even though we don't know if this is a real threat or not, it's something that we need to look at, because we have to be prepared.
I think we've got another question from Pavlos. Pavlos?
Hello again.
Hello.
How difficult is it for someone to be involved in Concordium? For example, start developing application or understanding more?
I would like to say it's really easy, but I have to admit, that it still requires a little bit of effort. But you can get all information from our website on the tooling that we have, how to make smart contracts, how to build a node. If you want to run a bake, you can also download the software for a node. So you can download that, and yeah, you can start running a node. You can start being a baker if you buy some of our cryptocurrencies, which is called CCD. But building applications, we have a smart contract layer. So on-chain, it is WebAssembly, and the idea is to have many different smart contract languages. Right now, we are supporting Rust as a smart contract language, so you can write smart contracts in Rust. And then when they're deployed as WebAssembly modules. So you can start with that immediately. That is possible. You can get information about it on our website. If you have a good idea for application you want to build, you can apply for a grant also at our website and get some support.
That's great. Thank you again.
Great. And how do you think toolkits are being developed? Because obviously you need software developers to build applications. And as you say, it can still be a bit clunky, and probably Hyperledger is the closest to building that toolkit. Where are we, and how could we better create our toolkits?
Yeah, I'm not quite sure how to answer this. What is really important in the blockchain world and is to create good tools, a good environment for developing smart contract ways for tokens or for other purposes. It's important, as we discussed earlier, to have good tools for ensuring that the smart contracts are correct. So if you look at a D app, most of the app would not be on the blockchain, but there'd be some sensitive parts of the security critical parts would be part of the smart contract. And it is important that these security critical parts are correct and secure. So I think we need tools and to better prove, verify smart contracts, ensure that they're correct. And that also affects the smart contracts for handling tokens. And this again comes back to what I said earlier. I think we have seen a number of attacks on different smart contracts, and we really need to do this better than we do today to have a trustworthy system for, also for tokens.
Okay, and then we've done a reasonable job with encrypting at rest and over the air, but the last bastion is in process, in memory, and homomorphic encryption is seen as one way to overcome that.
Yeah.
And many people say it's the holy grail, but there is a massive computational overhead. Do you see any movement in the usage of homomorphic encryption, or do you think it will stay as an academic exercise?
No, I think we will also see it used in practice. But as you say, it also depends a lot on how much or how fast it can be, because it shouldn't be a bottleneck, but it can be. Again, we have to remember that very often, if you have a crypto system or cryptographic solution, you have a hierarchy of keys. And maybe it's good to use homomorphic system for some of the top keys in the hierarchy where they're not so critical in the performance at the lower layer. So yes, we will see it, and I mean, we see it already, but they're also, but it's not going as fast as maybe some people would hope.
And
I think it's good to have the homomorphic encryption and the cryptography based on multi-party computation as an addition to just using hardware security modules to protect keys. Yeah, and I definitely see the need for that, and we'll see it more used, but how much depends on the efficiency of the solutions that we get.
Yep. And the internet we've created is very centralized. So we saw it with Facebook. Facebook took themselves offline for nearly a whole day, and we see routing protocols mucking up and DNS problems and so on. We created this centralized infrastructure. Also, countries can block content in certain geographical areas, as we see with these countrywide firewalls, where countries can keep control of their citizens and the information. So the proposed solution is towards this distributed data infrastructure around the interplanetary file system, where we use a Tor type, a BitTorrent type infrastructure. What's your feelings about using IPFS? Is it a risk to citizens, or is it the way that we free information? How might we build on this layer?
Yeah, that's a good question, and this is one I don't have a strong opinion about this. I would, yeah. So I haven't looked into the advantages of disadvantages of this, but I would say that a decentralized storage system or decentralized infrastructures, I think, can help with many things to avoid control. Whether it can help with the problem you mentioned before, where some countries simply cut off some functionality, I'm not sure, really, to be honest. I think they'll always find a way to do that.
Yeah, it's a difficult thing. I think there's no encryption in IPFS. It's a foundation layer, and things need to be built on top of it. So it's a very difficult problem, especially GDPR and the right to be forgotten. There's no guarantee in an IPFS infrastructure that your documents will ever be forgotten. But maybe they will support that in the future.
Yeah, but that is definitely a good point, because yes, because there's some information that you simply need to be able to delete, and if you don't have any control over it, that will be a problem with GDPR and with personal health information, what have you.
Great. Well, we've used up an hour of your time, and we're so grateful of that. I mean, such a privilege to talk to someone like yourself, who's really seen it all in the industry, and your vision and your drive. It's amazing for our students, especially as they're just learning these methods. So hopefully you've helped to for them to be more critical of the future and where things are going, and to make their own judgments rather than listen to others. So thanks very much for the for that. Oh, I've got one last question here. So we've got a question: can the Pedersen commitment scheme be adopted into a lattice-based one during the post-quantum era? Oh dear, that's a difficult one.
Yeah, that's a difficult one. It definitely requires some work. I think we need to come up with a new solution, because the commitment scheme really depends a lot on the group operations where it is implemented. So we probably need to come up with something else.
Yeah, that's a whole research paper.
It is.
I'd love to work on that. That sounds excellent. We did lattice-based today, but we just touched the surface of it. We didn't go into the detail of it.
I think the lattice-based systems are so complicated, to be honest.
Yeah, I agree. Well, Rainbow was interesting because it got hacked even before it got to the final. So that one was gone. So all we're virtually left with is Lattice, and Sojourneys are a way back, but they are a favoured son of the research community. So it's going to be a really interesting time. Lightweight crypto is going to be standardised. Post-quantum crypto will be standardized with an alternative. So I think we're looking forward to this whole world changing. And cryptography has always evolved, and it's always supported old and new.
Yeah, and I think but I always get surprised with the new things that come up. A lot of good ideas, and we'll definitely see solutions also for the post-quantum area. I just hope we get them in time.
That's great. Yeah. Great. Well, thank you so much. I don't know if some of the students just want to unmute themselves, and just a round of applause for Torben. That was really excellent.
Thanks. I just want to thank you all. I'm nice. Many people want to show off for this kind of view.
Yeah, it's great. Okay, well, thanks so much, and hopefully we'll see you in Edinburgh sometime soon.
Nice,
once we all go back to normal. I think it's quite easy to go from Denmark to Edinburgh. 2 hours, maybe.
Yes, it's quite easy. Yes, it is.
2 hours. We have excellent Danish students in the university, always first class students. So anything we can do to build up the collaboration between Edinburgh and your home country is very good, because you're the best place to live in the world. You're one of the most cultured civilizations on earth. So, and in your academic infrastructure and your research and industry is always at the best standard. So I think the world has a lot to learn about the goodness of the country and the way it looks at things. And I'd hope that we were aspiring to be like that too. So thank you so much, and
thanks a lot, and thanks a lot for inviting me.
Yeah, no problem at all. Okay, well, thanks very much, and hopefully we'll see you soon.
Yeah, I hope so.
Okay, thank you. I just stopped recording.